All right, welcome to part 2 of our reaction rates and equilibrium activity. Let's wrap up with doing some problems, doing some math, because what's a chemistry lesson without some math, right? So we're going to work on calculating equilibrium constants. So we're going to be given a problem like this, and we're asked here, what is the value of Kc? So that's the thing that we're trying to find right there. We want to find our value for Kc. That's our goal. And we're told the concentrations of our chemicals at equilibrium. So H2 is 0.20 moles per liter, I2 is also 0.20 moles per liter, and HI is 1.47 moles per liter. So here's our equation. We can see that everything's gases, so they're all going to be included in our expression. And so we're going to put our products over our reactants. So HI goes on the top, and then H2 and I2 go on the bottom. And our exponents, our coefficients, are going to become exponents. And so now we're going to plug in our values right here. So our 1.47, we're going to plug into our equation right there. And then these 0.2 values we're going to plug in down below. And now we just chunk this thing through our calculator and we come up with a value of 54. We're limited to 2 sig figs by our concentrations of our H2 and I2. So 2 sig figs there. And I want you to notice also, Kc is an unusual number. It's pretty rare to encounter a number that doesn't have units in a science class, but people usually list the equilibrium expression without units. So no units for Kc. And so our value here is 54. All right. So here is another example. Calculate the Kc for the reaction below. So if we look at this one, again, these are all gases, so they'll all be included. Our products go over our reactants. So CO and H2 go on top. The 3 right here is going to become a cubed in our expression. And also, we're going to plug in our concentrations right here. So these concentrations are all going to be plugged into our equilibrium expression. There we go. And then we just run this thing through our calculator. And once again, we're limited to sig figs, and we have a Kc value here of 0.26. So we have a smaller Kc value for this particular reaction. So again, there is our value of Kc. Once again, it's listed as being unitless. So please pause the video and complete question number 7. All right, welcome back. So let's take a look at another problem. So these problems in this chapter, the math problems, will generally follow a pretty simple format. You'll have to write an equilibrium expression, and then you'll be given all the numbers for that expression but one. So in these problems we just finished, we're given all the numbers but the value for Kc. But the other type of problem you might see is you'll be given Kc and all the concentrations but one and asked to solve for that missing concentration. So let's do a couple examples of problems of that sort. So here we have a reaction, and it's listed right here. This equation's balanced and all our materials are gaseous, so they're all going to be included in the expression. And we're given our Kc value right here, so bang, there's that value. And we're told that the concentration of PCl3 and Cl2 are both 0.1 moles per liter. And we're asked to find what is the equilibrium concentration of PCl5. So we're going to start these problems out by writing the equilibrium expression. So products over reactants, solids and liquids are omitted, and coefficients become exponents. So here is our equilibrium expression. But now we have to rearrange it, because we don't want to solve for Kc, we actually want to solve for PCl5. So we're going to have to rearrange our equation, and when we do that, we end up with PCl5 equals PCl3 times Cl2 divided by Kc. So if you can't do this type of algebraic rearrangement, you might want to go to the Learning Support Center and have the math tutors help you with that. Again, there will be a rearranging of equations required in this chapter, and it may have been a while since you've done that, so you might have to brush up. Once we've rearranged our equation, we're ready to plunk in our numbers. So here's our Kc that's given in the problem, and then here are our values for our concentration of PCl3 and Cl2. So this is all data from the problem. We plug that in and we come up with 0.24 moles per liter. So this is a concentration. That's actually what these brackets right here mean. The brackets represent our concentration in moles per liter, which we abbreviate with our uppercase M. So again, when you see those brackets, that means molarity. So once again, our molarity of PCl5 is 0.24. So let's do one more example of solving for concentration. So again, we're given all the pieces for this problem, but the concentration of one of our chemicals, which is the Br2. So we want to find what is the concentration of Br2. So we have NOBr, two of those react to form two NOs, and we also make a Br2. Everything's gaseous here, so they'll all be included. And our coefficients here will indeed become exponents. So here's the equilibrium expression. But we don't want to solve for Kc, we want to solve for Br2. So we're going to have to rearrange our equation, and when we rearrange our equation, we end up with this right here. So again, if you don't know how to do this rearrangement, you'll have to brush up. And now we're just going to plug in our numbers from the problem. So here is our value of Kc. Here is our concentration of NOBr, and here's our concentration of Br2. We plunk that in our calculator, remembering to square the things that need to be squared, and we end up with 0.78 moles per liter. And once again, we're limited to 2 sig figs. So remember, these brackets right here, these mean concentration. So when you see these brackets, it's concentration, and your units will be moles per liter. So congratulations, you survived the video, and I'd like you to go ahead and end the video and please complete question number 8.